Hello everyone. I'm Andy from ThinkMo. I'm currently teaching CCIE courses. From today, I'm going to share with you a little bit about CCNA, CCNP, CCIE related technologies. Our topic today is: how does OSPF accelerate network convergence? For example, under the current MA network. MA means switched network. We also like to call it broadcast networks. Under the current Ethernet network. In OSPF, there is hello time involved. And data time. Hello is sent every 10 seconds. The data time is 40 seconds. And that means that the convergence of the network is 10 seconds and 40 seconds. It mainly takes 10 seconds to receive hello. For the convergence of the network, it's just not acceptable. That's one aspect of it. Then there's the SPF algorithm. OSPF is called open shortest path first. The open shortest path is preferred. So what it does is it uses SPF. It's called the tree algorithm. It's acyclic. In other words, in the region. What SPF guarantees is absolute looplessness. So of course there are other interregions. Let's say there are some special cases involved. We'll come back to that later. How can OSPF networks accelerate convergence? We mainly have the following ways. The first is PRC. It's called partial route computing. Like PRC and ISPF. Including some other accelerated convergence methods. Is in OSPF by default. This is when the route on the network changes. It recalculates only routes that have changed. Just calculate where it changes. We can also think of it as a distance vector routing protocol. The incremental updates mentioned in it trigger updates. Something like this. So we all know the SPF algorithm. A tree has a trunk and leaves. So let's simply compare it to a tree. Normally when the leaves fall off, then it's normal. If there is no PRC, the whole OSPF needs to be recalculated. From the root to the branch. And then to each leaf. It's relatively tedious. It also consumes some of the device's resources. It's totally unnecessary. It's just a leaf falling off. So why recalculate? So PRC is called partial routing. Let's just count this leaf. You can think of it as a router. It's connected to multiple routers. This router is the root of the tree. All these other devices. We are in the network. Think of it as a tree. Between routers and routers. The lines they are connected to. You can think of it as a tree trunk or a branch. And then these networks underneath the router. You can think of it as a leaf. It recalculates only routes that have changed. This is PRC. So ISPF is mentioned in ISIS. It is also a routing protocol similar to OSPF. It's called Link State Routing Protocol. It's pretty much the same as PRC. What's the difference? PRC does not count nodes. ISPF computes nodes. What do I mean by nodes? It's a router. So that's all we have to say about these two aspects. There are other ways of accelerating convergence. For example, an intelligent timer in OSPF. You can set the time for updating SAS. And the time for receiving LSA. It's actually SPF calculation time. The SPF calculation time is enabled by default. Then update LSA time. And the time to receive the LSA, what does that mean? That's OSPF. It synchronizes the link state database. So we update the SLA and receive SAS. In other words, when the topology changes. Like the concussive jitter of a route. Let's say the line is unstable. It gets better and worse. In this case we call it jitter. Every change. based on the previous PRC. It doesn't have to be recalculated, although the route that has changed is recalculated. But frequent computation. The SPF network is unstable shock. So smart timers. You can set the time for updating SAS and the time for receiving LSA. The more you shake, the slower it takes to update. If the first time is 1 second, jitter once. The second time is another 1 second jitter. The first time I did it, it could be 10 seconds. The second time is 20 seconds. Exponential growth. Or multiply. So the third time, 30 seconds. Fourth time, 40 seconds. All the way up. So what's going on here? You can refer to Huawei's official manual. The second is the second aspect of OSPF. Convergence priority of OSPF routes. For example, to speed up certain networks. Which routing entries are more important? I want it to converge first. So I'm going to prioritize these routing entries. So you can get OSPF to configure it. Convergence is based on priority. Which line route has a higher priority? Preferential convergence. After the convergence of the configuration priority, converge the others. Then there's Smart Discover. That's what we were talking about with hello. For example, hello is sent every 10 seconds on the network. It will take 10 seconds to receive hello. When things change, 10 seconds is too slow. Once Smart Discover is configured, on the interface it doesn't wait 10 seconds anymore. You can just send it. In this way, OSPF convergence is accelerated. The other party can receive the hello packet earlier. Networks that enable OSPF. Faster convergence. Secondly, modify the hello timer of the interface. Change the default value from 10 seconds to 2 seconds. The fifth is BFD. Combined with some other features. Interworking like BFD for detection. Once the OSPF network topology changes are detected, or the neighbor has a problem, OSPF immediately responds. That is to say, in combination with the others. The tool interworks with OSPF. It is detected by OSPF. And then it tells OSPF if there's a problem. In this way, OSPF convergence speeds up. It's like someone hitting you. You're reflexive dodging. Then try to avoid the presence of DR. So in OSPF, there are corresponding network types, like P2P, P2MPMA and NBMA. Let's say two routers. It's connected by a line. Something like this network type. Let's call it point-to-point. By default, the OSPF network type is MA. We can go under the interface. Example, change the OSPF network type to point-to-point. That would reduce DR's campaign time. It's not exactly a decrease. I'm not going to choose DR. You've seen a lot about DR in the previous video. The DR choice will wait for the corresponding time. Usually 40 seconds. That's what we call time of death. That must be a long time. So I'm going to change it to point-to-point. You don't have to elect it. So it's going to converge faster. The seventh aspect is like configuring some special areas. Some summary route. Do a summary of the routes. To reduce LSA flooding. In this way, the overhead of SPF calculation LSA is reduced. It is possible to compute many LSAs through some optimization of special areas. Is the internal optimization of OSPF. You can compute fewer LSAs, so we can achieve rapid convergence. That's it for today. If there are any other skills you'd like to learn, feel free to leave a message or send me a private message. If you're interested in what I'm talking about, hope to like and subscribe more. Thank you. See you next time.